Okay, so yeah, thank you so much. So just like before I start, I have my colleague Matthew because typically like my lectures they are interactive, so I need someone to ask. Otherwise, it will be like as I am asking myself. So good morning everyone. Today we will explore a fantastic topic, the chemical equilibrium. And just before we start, let's ask a question. What comes to your mind when you hear equilibrium? So, Matthew, what comes to your mind when hear equilibrium?
I'm thinking about scales, like balance, like when something is equal.
Perfect. Exactly. And by the way, my Matthew is super smart, so it will be quick. So exactly, equilibrium is like the scientific word for being balanced or being stable. So again, like our textbook is the chemistry second edition from Rice University. So this is like what we follow. So before we going forward in the chemical equilibrium, just let's give a reminder for our previous like chapters that we discussed in our textbook. So in the beginning, we started by the atoms, how the atoms, like what the part of the atoms, and how these atoms form the molecules and the bonding and the states of these molecules, either like gas, liquid, and solids. We studied the molecules in solutions, and in the last chapter we studied kinetics. So kinetics is the chapter 12. And kinetics, which is simply we can put is from baking a cake to determining the useful lifetime of a bridge. Rates of chemical reactions are play important roles in our understanding process that involve chemical changes. So in this, there's two key words. If you Matthew can guess, in the kinetics there is two main keywords. Do you think what they are? We mentioned them now. Just I need to. What is the kinetics?
Like speed and energy?
Again, sorry.
Speed and energy?
Exactly. Speed is rate. Yes, rate, and not energy. Actually, we mentioned now is reaction rates, which is exactly rates at the speed that you mentioned. So reaction rates, we're speaking about two main key concepts in the kinetics. And in the chapter, again, as a reminder, we started by reaction rates, factors affecting rates, rates law, integrated rates law, rate laws, sorry, collision theory, reaction mechanism, and catalysis. And before moving forward, the reaction rate is important to understand, or again, is important to remember, because that what we will build on in the chapter of chemical equilibrium. So, Matthew, what do you think about chemical reaction? What is the chemical reaction?
It's like when you mix two molecules and they become one together.
Exactly. Is a chemical reaction is a process when reactants, it can be two molecules and more, they can break bonds and form a new ones. This is a chemical reaction. And what are the reactants?
It's the thing that we are at the start.
Exactly, starting material, Matthew. Super. And by the way, Matthew is electrical engineer, not chemistry. that's that's impressive. And what are the products?
It's like what I'm left with at the end.
Exactly, is the new substances formed as a result of chemical changes. And reactions, as we discussed in the previous chapter, it can either go in both directions, forward and reverse, or like forward, backward, or can be go in one direction. And there is a scientific description for them. Can you guess what they are?
I think the answer is on the slide.
The answer, sorry, again?
The answer is on the slide.
The answer in the
Like,
slide.
yes, you have
No,
the
no, no,
arrows
there's,
pointing like
yes.
this or like that.
So which is again, there is two types. So the first one, which is like the reaction can go forward and backward. There is a name under the box, and it can be shown in the two side arrows or like two arrows, and the one that goes in one direction and it's showed just in one arrow. And these are reactions, what's called reversible and irreversible reactions. For students who love to summarize their information in a table, this table summarizes the definition for the reversible irreversible reactions. So the reversible reactions, as we mentioned, is the one that can go reaction can go in the forward and reverse directions until equilibrium is reached. And if you notice now, from this point, when we speak about reversible reactions, you start hearing about equilibrium. So equilibrium now becomes a very important concept with reversible reaction. Irreversible reactions is the only ones that, or the ones that can go just only in one direction. So the reactants will be disappear and new products will appear. Examples for these reactions, one of the most famous examples for reversible reactions, as we will show in the next slides, is the formation of and dissociation of ammonia. It's called as Haber processes. And also dissolving salt in water that can dissociate the salt to ions, and then you can again extract the salt again either by crystallization or evaporation the water. Irreversible reaction as the composition of a wood or fuel to form the carbon dioxide and water, or cooking an egg. It will be nice, of course, if we can return that cooked egg to one raw egg, but so far I don't think it is possible. Matthew, can you think another example for reversible and irreversible reactions, just like one example of each from real life?
in your life.
Uh, for example, like let's say, like because you are working in electronics and using like such of these materials like nanocomposites, is it possible if they can be separated again, or like they will
No,
be,
if I mix powders together, it's irreversible.
so it will be like a new material, like a
Yeah.
new, okay, so this
No, like
kind
if
of
I make a cake, like the dough, I can't separate the things again.
perfect. So this one reversible or reversible?
Irreversible.
Reversible, perfect. Reversible one.
I think like there's a reaction that changes color depending on time. Like it goes red then blue then red then blue then red then blue.
Yeah, it can be. It can be. So these, yeah, reversible reactions. Nice. Okay. But of course, because of limited time, we can give more time to think about other examples. So now we will go for the equilibrium, because now when we hear about reversible reaction at the chemical equilibrium, so we now we understand, we want to go like to understand what is the equilibrium, chemical equilibrium. And in this chapter, we will cover different sections, introduction, the chemical equilibrium constants, the Chatler's principle, and we'll do at the end equilibrium calculations. This chapter is number 13 in our textbook, starting from the page 657. At the end of today's lecture, you should be able to define the chemical equilibrium, define the key features of chemical equilibrium, and understand the dynamic nature of chemical equilibrium. So again, we already like spoke about equilibrium in life, or like because it's connected with the reversible reaction, so we may have an idea. So again, Matthew, you mentioned that equilibrium in life is
Like when there's balance.
balanced, exactly. So so equilibrium means a state of balance or stability where opposing forces or influences cancel each other out, resulting in a steadiness and harmony. And simply put, is not actually steadiness or stillness, but is a rather a state of things being balanced and stable in everyday life, like a tightrope walker keeping balance while moving, or the market reaching a price where supply and demand are equal. Do you have another example from life about balance, about equilibrium?
Like if I fill my faucet, at some point it's going to either go overboard, so the water stay in the sink stay constant, or if I'm lucky, there will be a hole that will make the water go away. At that point, like the amount of water still stays the same. Thank you for the
I
picture.
as I said, like you are smart, so I guess look, you took the idea from this small picture. Perfect. So, and again, as we mentioned that equilibrium is connected with irreversible reactions where the forward reaction, reverse reactions, they are balanced, they are equal, that we can reach then the equilibrium. So where we speak about the rate of forward and reverse reactions are equal, but not the concentrations of the reactants and products. So this is important. And before we move forward, I think like let's watch this video. It can give you a better idea about chemical equilibrium. Okay, let's perfect. So what they mentioned here, uh, if you noticed, is a dynamic state where the forward reaction and the reverse reaction they become balanced, and that it means that the concentration of the reactants and products will be constant, but it doesn't mean that they will be balanced. They will be constant, but they will not be balanced. The one that will be balanced is are the rate of reactions. And as you noticed in the beginning, there just only uh, the reactants and then products will be balanced. That it means that chemical equilibrium. So which means that let's focus now the key features of the chemical equilibrium. So it happens only with reversible reactions. So equilibrium occurs only reactions that can proceed in both directions. Concentrations, but not equal concentrations. So this is important. So the concentrations of reactants and products remain stable, and this is happening in equilibrium. And again, Matthew, equilibrium it means the rate of the forward reaction and reverse reaction. What?
Equal?
So the constant reaction concentrations it will happen at equilibrium. Sorry, did you say that because?
Yeah.
Yeah, because I thought like you said a French word. And this is it's still maybe early, but okay, it's important to point at now that this it happens in closed systems. A closed system it means and under certain conditions. So closed system, it means that no matter enter or leave the system, which means no change in the concentrations, either products and reactants. I mean, you can't because any change, any manipulating in their concentrations will shift the equilibrium. They will shift the reaction rate to reach the equilibrium again. And it means that no, under certain condition, it means that no change in the factors or the parameters of the reaction, such as the temperature, pressure, and as we mentioned, just concentration. One of the best examples of chemical equilibrium is Haber-Bosch process or Bosch process, if I pronounce his name correctly. So Haber is the pioneer, the one who pioneered the formation of ammonia by the reaction of nitrogen and hydrogen at a specific under certain condition of temperature, pressure, and using catalysis. It's very important understanding the equilibrium because it's predicting the reaction behavior and that it can optimize the industrial process and controlling the natural chemical phenomena. I can give an example from my research about using gas sensors and how could I understand the mechanism of the my sensors to enhance their performance. But we'll stick now just because of limited time, we'll stick with this example. So understanding the equilibrium with the Haber reaction, it helped to maximize the ammonia yield, which is very important and actually one of the reasons to revolutionize the agriculture industry because of the production of fertilizers that help the global food production. And without understanding and managing equilibrium, such a large scale synthesis will not be possible. This is one of the examples to understand why we are studying equilibrium. It's not we are studying equilibrium because it is exists in the textbook or because we want to, but because it's very important in chemistry. And as we mentioned in the beginning, we are building in the knowledge one on top of each other. In the next lecture, we'll speak about equilibrium constant. We will go for the definition, the significance again, to understand the importance, how we write the expression, and this one, it shows briefly how we can do this. We'll discuss it next lecture, and how we can interpret the key value, the equilibrium constant. What does it mean, large K, small k, and what does it mean, K equal 1? And so now we finish and we'll do the conclusion. So, Matthew, just what are the takeaways today and what are the things that you can conclude? Like, what are the keywords that or key concepts that you heard?
Like there are two type of reactions.
Perfect.
Some of them, like they can only go forward, and then like, once it's done, you can't go in the past. Some of
Exactly.
them, they start by going forward, but at some point they will go back, and then they reach a new point where like both we won't destroy everything if we just have something that way there, some new
Perfect.
things, but we have new we don't destroy everything.
Sounds good. And so the equilibrium exists with which one?
Equilibrium is with the reversible reactions.
Perfect. And as we said, is it like equilibrium reactions or the reversible reactions? Equilibrium, is it something like static or something still alive? Like something working, still
Like
working.
if you give me $2 and I give you $2, I still have the same amount of money at the end. It's just that at some point it's like different coins that I have. So it's that
Is
it can change all the time.
That's like, I mean, you made the fair points. So exactly, we spoke about reversible reactions, and with that where the equilibrium, like the equilibrium exists with the reversible reactions, that when you have equal reaction rates, that the equilibrium should be closed system. So there is no change in the concentration of reactants and products. So the equilibrium constants, so that we'll speak about next lecture. We said like the equilibrium is dynamic state, so like the forward and reverse reaction, they are continue happening, so they are dynamic, alive, and constant concentrations, that the result concentrations, they are equal, but sorry, the concentrations of reactant and product, they are stable, but the rate of reactions forward and reverse, they are the ones that equal. And the equilibrium position, that the equilibrium maintained under certain condition, manipulating temperature and pressure can change the equilibrium again. So this is for today. As for assignment for next lecture, please, students of four, we should prepare one slide of another example of from the industry about the chemical equilibrium and why it is important. Be aware that the same example we will use for the rest of the chapter. So we'll do calculations and of calculating the equilibrium constants and for the other calculations at the end. And again, I encourage students uh, to change the groups that they had in the previous assignments. That will help between you to strengthen your bond, you to have a better understanding of each other, and to enhance the chemistry between you. So thank you so much. Again, be aware that our textbook is the chemistry second edition. Thank you so much, and I will see you next lecture. Thank you.
Thank you so much. Bye.
Bye bye.